Today we are going to introduce quadratic equations and how to solve them. Really there are four different possible techniques that we can use for solving quadratic equations, and today we're going to start with usually the simplest method, or the one that we usually go to first, at least try it. And let's first of all let's talk about what a quadratic equation is. It's an equation that can be written in the form of ax squared plus bx plus c is equal to 0. Okay? Most quadratics, whenever we see them, I can tell that this is a quadratic because a, b, and c here are all real numbers, and a cannot be 0. Otherwise, if a were 0, then I would really just have bx plus c equals 0, and that's really just linear. So that's the only requirement. So a quadratic equation could be just ax squared equals 0. It could be ax plus bx equals 0. It could be ax squared plus c. So as long as there is an x squared term and it's the highest exponent and there's no other different kind of exponents except for a plain x and a constant, then we know that it's quadratic. So to solve this, the reason that we first of all we always set quadratics equal to 0 first. So if we see this, we think, oh, we should make it equal 0. So if there was a number on the other side of an equal sign, we always use 0 on the right-hand side. And that is because we use that 0 to our advantage. We use what is called the zero product property. Okay, so let me give you an example here. I have x squared plus 9x equals 0. Okay, now this is a slightly different quadratic, but it does have an x squared. It just doesn't have the c on it. There's no constant, but the b in this case would be 9. And so it's definitely quadratic, and we use the zero product property because what we want to do is we want to turn this into multiplication, because the zero product property says if we have two things multiplied together, let's say we have a times b is equal to 0, then if I have 0 on the right hand side and I multiply a and b together, then there's no way, if I know that a is a number, then that means that b must be 0. And if I know that b is a number, then that means that a must be 0. So we turn it into multiplication so we can use that thought. Okay? So this is an example of, this is kind of, the first line of defense is always to look for the greatest common factor. Okay? In this particular case, the greatest common factor is x. There's an x in the x squared and there's an x in the 9x. So we factor out the x. We put the x on the outside, we open our parentheses. There are two terms here. That means there should be two terms in here. I never want to lose one. Whatever number of terms I have to start with, that's how many terms I have in the parenthesis. So now I need to multiply x times something here that'll give me x squared. So I already have one of the x's. I need 2, so this is an x. And then I need something here to multiply. I'm going to need a plus because this is a plus. So x times what will give me 9x? Well, it will be 9. So I close my parentheses, which are already there, and I have equal to 0. And so now I have this x times x plus 9 equals 0. If I have two things, they're multiplied together, and they're equal to 0, then that means that either this first one has to be 0, x equals 0, that comes from this one, or x plus 9 equals 0, implying that x equals negative 9. And so my quadratic equations can have 0, 1, or possibly 2 solutions, as I just showed. This one had 2. Alright, so I always want to look for the greatest common factor first to see if I can factor it that way. So another type of factoring that we can use, we want to do the same thing. We have x squared minus 2x minus 8 equals 0. Again, my equation is equal to 0. If this had been x squared minus 2x equals 8, then my first step would be to subtract 8 from both sides and turn it into this. I always have to have 0 on the other side because there's no other number that if I multiply two things together equals a different number, then there's no guarantee about what has to be in the parentheses. Okay. So in this particular case, When we're factoring, this is called a trinomial. It has 3 terms. This one up here was a binomial because it has 2 terms. Trinomials usually factor into something that looks like this, right? You have x plus something or x minus something, and they usually look like this. And so this is what we're going to try to do. So the way that we figure this out, okay, if I multiply 2 factors together, let's make a little side note over here. If I have x plus 1 times x minus 2, and I multiply these together, when I multiply these 2 things together, basically each thing in here needs to get multiplied by each thing in here. And so I can multiply, if you ever heard of the sort of the moniker FOIL, F stands for first, so we multiply the first 2 terms together. So x times x gives me x squared. O stands for outer terms, so that means I'm going to multiply the 2 outside terms together. So that's negative 2 times x, so I get minus 2x. Then my I stands for the 2 inside, so I'm going to multiply these 2 together. So I have positive 1 times x, which is x, 1x. I just don't write the 1 because it's implied. And then I have positive 1 times negative 2, which are the last. The L stands for last. Positive 1, negative 2. You don't have to do them in this order. It's just, it's kind of nice because then you don't miss anything. I don't usually do it in that order when I do it, but you can, it's a nice way to remember. And so then the last thing I have 1 times negative 2 is negative 2. And so I can combine my terms then. So I have like terms here and here. So this is actually x squared minus x minus 2 when I multiply it together. So what I want to point out is that these 2, this here, came from the first 2 numbers being multiplied together, and the negative 2 came from the last. The O and the I, the outside and the inside, come from a combination, right? The middle term comes from a combination of the outer and the inner term. So we want to keep an eye on that, okay? So in this particular case, right, if I just have plain x squared, because it comes from the first terms, I know that this first term has to be x and x, okay? So to figure everything else out, I look at this last sign, okay? So the last sign of my binomial or my trinomial is the thing that tells me about my signs inside my bracket, okay? If my last sign is positive, which in this case it is not, right, then that means that both of my signs match. And they always match the first sign. So if this were minus 8, right, or this was plus 8 instead, and then this were minus, then that would mean that both my terms would be minus minus. So when this last sign is positive, they always match, and it always matches whatever this one is. And that's because if this last term is going to be positive, that either comes from a positive times a positive number or a negative number times a negative number. So that's how we figure that out. If our last sign is negative instead, then that means that my signs have to be opposite, which is clearly the case. That's what we have in this case. So our signs are opposite. Since we don't have any numbers in front of our x's, I'm just going to put in the opposite sign so I don't forget. I have x's plus and my x minus. The next part, my last term here, comes from multiplying 2 numbers together to give me the 8. Now my number is negative 8, so possibilities, right? I could multiply 1 times 8. I'm going to ignore the sign for right now. 1 times 8 or 2 times 4 gives me 8, right? So now I'm looking for, since my sign is negative, one of these, basically these 2 things, if the difference between them because of the minus has to be 2. That makes this 2 times 4 the one that we want, because the difference between 2 and 4 is 2. Now we want the inner term to be negative 2. So that means in this case, one of these has to be positive and one of them has to be negative. In order to get negative 2, I would have 2 plus negative 4. So that means I want the 4 to be in front of the minus and the 2 to be in front of the plus. So I have it factored. I can always check it, right? Because this is 2x. This is negative 4x, and when I add them back together, I get negative 2x. So once I have it factored, now I set each one of these terms equal to 0 separately. So I have x plus 2 equals 0, giving me x equals negative 2, and x minus 4 is equal to 0, giving me x is equal to positive 4. Okay, so that's our simplest type of quadratic. All right, so let's look at another one. Another interesting example. This is x squared minus 9 equals 0. Now this is one of the special cases. Normally, if I only have two terms, then I usually have a greatest common factor situation. Like this one here had just two terms. Both of them had x's in it, and it was a greatest common factor. This is a special case. When I have the quadratic term, the x squared, and then I have a minus and a constant, this is what we call a difference of two squares. So that means I have two perfect squares separated by a minus sign, and there's no x term. And what that means is this will factor, right, into almost identical factors. I know that to get my first term, I'm going to get x and x. I have a minus as my constant, so that means my signs have to be opposite. And then I need my middle terms to vanish, so that means that the plus and minus have to be the same. So that means it's 3 and 3, right? I notice right away that it's a difference of two squares because I know that x squared is a perfect square and 9 is also a perfect square, and there's a minus in between them. So I have x plus 3 and x minus 3 is equal to 0. I set these each factor individually equal to 0 because my zero product property tells me that either this one or this one has to be 0 in order for this multiplication to end up being 0. So I have x equals 3, or this one ends up giving me x equals negative 3 when I subtract both sides. X minus 3 is 0, gives me x equals positive 3 if I add 3 to both sides. Okay, so let me just do one more simple quadratic. X squared minus x minus 6 equals 0. Right? So again, when I just have the plain x squared, I know, or at least I'm going to try to make it, I put my x's in the front because I know that the first terms come from x times x has to give me x squared. All right, I look at my last sign. The last sign is negative, meaning that my signs have to be opposite, so I'm just going to put them in. If it weren't just plain x and x, I wouldn't put them in. We're going to do an example like that in just a second. Okay, so now I want factors, two things that multiply together that gives me 6. So I have 1 times 6 and I have 2 times 3. All right, so I am looking for, since this sign is negative, again, I want basically one of these minus the other to give me this middle term, which is really negative 1 is implied. So that means I'm going to use the 2 times 3, because 1 minus 6 is negative 5, and 6 minus 1 is positive 5, right? So 3 minus 2 is positive 1, and 2 minus 3 is negative 1. So that's the one that we want. So that means we're going to have a positive 2 and a negative 3, because when I add those two things together, they're going to give me this implied negative 1 here. So that means my 3 goes in front of the minus sign, my 2 goes in front of the plus sign. And if I want to just double check quickly, I multiply these two guys together, I get 2x. I multiply these together and I get minus 3x. And this gives me negative x overall when I add them together, which is my middle term. The outer and the outside, those are really easy to check, right? Because x times x is x squared. Positive 2, negative 3 is negative 6. So usually the one that we're most worried about is the middle term. So now I set each one of these equal to 0 separately, so this means it has two solutions. I get x plus 2 is equal to 0. Subtracting 2 from both sides, I get x equals negative 2. X minus 3 is equal to 0 gives me x equals positive 3. I'm adding 3 here, and I'm adding 3 here. Okay? So I get, again, two solutions. I got 2 up here as well. All right. So let's move on to something that's a little bit more challenging. So this time we're going to have a quadratic whose leading coefficient is not 1. So I have 2x squared minus 19x equals 33. Okay, so this has a couple of different problems. 1, my leading coefficient is no longer 1. And by leading coefficient, I mean the number in front of the highest power of x. In this case, x squared, okay? So this is not 1. So that means when I go to make these parentheses, I'm not just going to have x and x. In fact, the only way that I can make 2x squared is to have 2x here and here, right? Because 2 is a prime number, so the only way that I can make it is 2 times 1. So there's no ambiguity there. It has to be 2x and x. Now the other problem that I didn't address is that the 33 is not on the same side of the equation as with the 2x squared. So I'm going to subtract 33 from both sides, here and here, which I'm going to write it underneath here. It's not the most organized, but I have 2x squared minus 19x minus 33 is equal to 0. All right, so I know with some certainty here that I have a 2x and an x because I know that this first term comes from, I need to make that. Now this last term has to make 33, okay? So I need these numbers to multiply together to give me 33, and it's negative. So my signs have to be opposite. Now I'm not going to put my signs in right now because I'm not sure which one's going to need the negative and which one's going to need the positive. But I don't, because of this 2, the way that it's multiplied in, we're not going to find factors of 33 that when I subtract one from the other I'm going to get 19. So instead we need to look at the leading coefficient times the constant term, which is 66, actually negative 66 if I include the sign. So instead, I want to look at, so this is one strategy, there's many more, so if you have a strategy that works for you, you can use it, but this is a strategy that works for me. So I multiply the 2 and the 33 together and I get 66. So I'm going to look at things that multiply together to give me 66. So I have 1 times 66. That's probably not it. What I'm going to look for is I want when I subtract, because this is minus, right? If it was plus, then I would be looking for them to add together to give me the 19. But I want 1 minus the other term to give me 19. Well, it's not 66 and 1. So how about 2 and 33? Nope, because the difference between those two is 31. How about 3 and 22? That, in fact, works, doesn't it? Because 22 minus 3 is 19, or 3 minus 22 is negative 19, okay? So I want to think about this for a second. That does not mean that these are the numbers that go here, because 3 times 22 is 66, and I need these to multiply together to give me 33. What this tells me is, okay, so I'm going to need a positive 3 and a negative 22 here, okay? So what I need to do here is I need to, these are going to be what my middle terms sum to. So if this is going to be negative 22, it seems pretty obvious that this has to be here negative 11, because 2 times negative 11 will give me 22, and then if I put the other piece here, so if I have negative 11, I need to multiply it by something that's going to give me negative 33, so that means that a plus 3 has to be there. Now I can check my middle terms again, so this is 3x and then this is minus 22, and I do in fact get negative 19 in the middle. So again, I set each factor equal to 0, and I get 2x plus 3 is equal to 0, which tells me I'm going to subtract 3 from both sides. I got to work for this one a little bit more. I get 2x equals negative 3, so I get x equals negative 3 over 2 when I divide both sides by 2. The other one is more straightforward. I have x minus 11 is 0. That gives me x equals positive 11 when I add 11 to both sides. So these are a little bit more challenging, but they're still very doable. Let me do one more that has a leading coefficient that's not 1. Okay, just so that we make sure that we get the hang of it, because these are the most challenging ones. I have 3x squared minus 14x plus 8 equals 0. Okay, so I have, again, a leading coefficient of 3. Now the good news is that the 3 is prime again, so that makes my, at least the first piece, relatively easy. I know that only 3 times 1 gives me 3. So that means there has to be a 3x in one and an x in the other, right? I could have written the x here, the 3x here. Multiplication you can do in any order. Okay, so the next thing that I want to look at is, so these two numbers have to multiply together to give me 8, but this 3 is going to affect the numbers inside. So I multiply the 3 times the 8, that's 24. It gives me positive 24. Now this is a plus, right? And that means both my signs will have to match, and they match this one. So that means that they're both minus minus, and since they're both minus minus, I'm going to go ahead and put them in. So now what I'm looking for are two factors of 24 that when I add them together, I get 14, okay? So that means, let's see, I have 1 and 24. No, does not work. 2 and 12, there we have it, okay? So again, I can't put the 2 and the 12 in here because if I multiply those together, I get 24 and not 8. But that means that one of these terms, right, is the 2, and one of them must give me the 12x, right? So that basically means that I'm going to have a 12x and a 2x as what ends up coming out of my middle terms. Well, I can kind of see that I don't want the 2 to be here, right? I want, because I'm going to need to get 12 out of it, so I'm going to need to put the 4 here to multiply the 3 and the 4 to get the 12x. And so now that means that that must mean that I'm going to get 2 out of this times this, so that means that there has to be a 2 here. Now I want to make sure that everything in fact works, right? 3x times x is 3x squared, and then I have a minus 2x here. I have a minus 12x here. When I multiply or add them together, I get negative 14x, and when I multiply negative 2 times negative 4, I get positive 8. Okay, so there we go. And now I just need to set each one of these terms equal to 0. So I have 3x minus 2 is 0, and x minus 4 is 0. So I'll do the easier one first. I just add 4 to both sides, and I get x equals positive 4. Over here, multi-step, I get 3x equals positive 2. I'm adding 2 in my head here, 2 and here, and then I'm dividing by 3. I get x is positive 2/3, and x is equal to positive 4. And that is how we factor quadratics. So look for the next one on extracting square roots.